another conditional probability. Okay, so the probability for the husband watches a certain television show is 0.4. Okay. And the probability that his wife watched the same show is 0.5. The probability that the husband watches the show given that his wife does is 0.7. So this sentence here, right? This sentence here is a classical sentence showing conditional probability. Now find the probability that the married couple, okay, now watches the show. A wife watches the show given that her husband does. Okay, so let's take a look at the first one here. Now, before we talk about this first solution here, let me show you some little bit variations about the formula of a conditional probability here, right? So, in the lecture notes, as we are in the first question, as pointed out, conditional probability formula is this. Okay, is this. Now, there's a slight variation as you look at this numerator here, right? This numerator, this PA and B also equal to P, B, and A, right? P, B, and A. So basically, if I replace this over here, right? So that means, right? First of all, PA and B equal to PAB and PB. Right? Now because this equal to that, so that means PB and A equal to PAB and PB. Okay, so that's a little variation here. Now the other thing is, right, if I replace this, if I just look at this formality over here, okay, and switch the order A and B here, right? So basically this switch, this one also become P of A, so that means this also equal to P BA and PA, right? Okay, so in other words, right, you look at this one here, so this also equal to this. Okay, this is purely mathematical variations here, okay, just from the definition of the formula. Okay, yeah. So now let's get back to this question here. So what are we looking for here? The first question is, what's the probability the married couple watches the show, right, together? So together means, let's say if I use W, okay, to represent the event wife watches a show, and H represent husband watches a show. Okay, so then for the first question, right, and then it becomes easy. The first question will be simply becomes what's that probability you're looking for is probability H and W, right, or P, W and H, right? So either way is fine. Okay, yeah. So let's say if I call this is A and this is B here, right? And that means if I use let's see, what do I use? Let me see if let's see what do we have here, right? What do we have here? So because the question what do I have here is I have the probability that the wife watched the show, probably H husband watched the show, and we also have the probability that the husband watched the show given the wife does this one here, right? Okay, so what we can basically in this one here, what would that be? That's basically P husband, right, W. So you know that under the condition W, when the wife watches the show, you have the probability of the husband to watch the show is 0.7. Okay, so I guess I have this condition here. If I have this condition here, let's see what do I use here. I basically am using here is just P W over here. Okay, so if I write this, okay, so that will be what? This is my A here, and this is B here, and this is A here, right? So, and that's exactly what we're looking at here. Exactly this one we're looking at this one, right? This formula. So this all these formulas are the same thing. I'm talking the same thing here. Okay. And we know P of W, and we know a P of HW here, right? So you can calculate. The second one here, what you're looking for is basically PWH. Okay. So use the conditional probability for this one here, and it should be okay. Okay. Yeah. So just for this question, understand the variations, okay, of all of these things here. Essentially, this is the key, right? PA and B equal to PB and A. Okay, this one, the number 4 question. Okay, the number 4 question is total probability question. So many times this total probability is a foundation for what we call the Bayes formula. Okay, the Bayes theory. So what happens is we find many times it's probably easier to use a tree type of illustration, right, for this kind of question. So then let's see, how do I draw this tree at here? Okay. So 3 urns, and there are some red and black balls in each one of the urns. If an urn is selected random, this keyword selected random here, which means, right, the probability of selecting each one of the urn is 1/3. Okay, so you have, right, 3 choices at the beginning, and this is urn 1, 2, 3. Okay, and the probability of getting each one of them is 1/3. Okay, and then from here, right, you have, okay, different probabilities of getting either a red or a black. Now, the probability of getting a red or black, okay, and that depends on the number of balls, number of red and black balls in each one of the urn. For example, for the first urn, there are 5 red and 3 black. So getting a red is what, 5 over 8. Getting black, 3 over 8. So each like that. Okay, yeah. So what are we looking for? We're looking for the probability of finding a red. So basically, you're looking for a red ball here, and this is a total probability. So a red under the urn 1, okay, and then multiply by probability to urn 1, right? And until probability red urn 3 and probability urn 3. Okay, so that's basically the total probability formula. Okay, now what's the conditional probability from the branch here? So this is a condition. This quantity here is what is the probability to red under the condition of urn 1, right? And this is where you plug in a number here. So now you'll be able to calculate the total probability of getting a red if you select randomly from one of the urns.